Hello everyone. So in this video I'm going to talk about the floating static route. So we're going to see how we configure this. Before that, I would like to remind you about this in Cisco, what is the default value for the administrative distance which are assigned to each routing protocol. For example, if you have connected interface or connected segments or LAN, the administrative distance is equal to 0. For a static route, it equals 1. EIGRP summary routes, the administrative distance is equal to 5. For EBGP is equal to 20, etc. So now, if the value of administrative distance is the lower it is, the best, so the router will always choose the route which has the lowest administrative distance and then put it in the routing table. So if the router learns 2 routes or more to the same destination, and it happens that these routes are learned using various or different routing protocol, so of course the router will choose the route which has the lowest administrative distance, and then it will put it in the routing table. For example, let's assume the router learns a route to one destination A, okay, using OSPF routing protocol, and then it learns a route to the same destination using the internal EIGRP. So now we have 2 routes to the same destination learned from using different routing protocols. So which one to choose? Of course, the router will go for the route which has the lowest administrative distance, which is internal EIGRP, because you see here the administrative distance of internal EIGRP is equal to 90, whereas for OSPF is equal to 110. So of course 90 wins because it's the lowest value. Of course, you can do this with the other routing protocols. Now, these values that we see here are default values. What does this mean? It means that you can change them. You can change them depending on the various scenario that can arise. Now, in this video, I'm going to show you how to use this technique of playing with administrative distance using static routes in order to create some kind of main routes and backup routes. So let's come back to let's go back to the diagram. So in this simulation using Cisco Packet Tracer, I have 4 routers. As you see here, there are 4 routers. Now RT1, now these routers actually are pre-configured with IP addresses. Now in RT2, I already configured all necessary routes, so all the routes that we need are already available in the routing table. Okay, so I can display the static routes only for you to see this clearly. Right now, in router RT3, I have done the same thing, show IP route static. Okay, so I configured all routers, so we're not going to do anything with RT2 and RT3. In router RT1, I have configured the following route, static route. So these are the routes to reach the point-to-point links 10.1.20, 10.1.30. So the routes to these point-to-point links are already configured on router RT1. The same thing, router RT4. I already configured this, show IP route static. Okay, so I already configured routes to segments 10.1.00, 10.1.1.0. Now what is left is just configuring routes on RT1, RT4, routes to reach the other LAN. For example, RT1, I will need to configure route to reach this LAN, and on RT4, I will need to configure routes to reach this LAN. But what I want that RT1, if RT1 receives a packet destined to this network 172.31.0.0, the packet will go through the primary routes that I designed here. So the primary route is a route that goes through router RT2. Okay. Same thing, if RT4 receives a packet to this LAN 172.16.0.0, RT4 will send the packet through the primary route, which means it goes through router RT2. Okay. Now, if something happens and all this primary route goes down, automatically RT1 will start serving or sending the packets through the backup route. And backup route will go through the RT3 router. And the same thing, if this route goes down, all the replies or any packet sent from RT4 to LAN 172.16.0.0 will go through the backup route. Now, in case this primary route will reactivate again, will be active again. So the problem is gone, and it's active, it becomes active. All the packets will go again through the primary route. So automatically RT1 will switch to the primary route when sending packets to this destination network, and also RT4 will switch packet forwarding through this primary route when it has to send packet through to this destination network. So the backup route here is just a route that we keep in case something happens to this route here, to the primary route. So if the primary route goes down, of course backup route will be used actually. So basically this is the scenario that we can imagine and that I implemented through the simulation. Of course there are other techniques that you can play with. I will talk about this in my at the end. So the first thing I will do, I go to RT1, and in RT1 I go to the global configuration mode, and then I start configuring a route to segment 172.31.00. So in order for RT1 to forward the packet to segment or LAN 172.31.00, okay, with this subnet mask, it should simply forward the packet through this exit interface serial 000. Okay, this is what I should do. Something like this. And you remember the administrative distance for static route is equal to 1. Now, okay, I go again here, and I will put another route through the exit interface is 001. However, if I keep it like this, both static routes will have the same administrative distance, and then the router will put both of them in the routing table. Both of them are going to appear in the routing table. So when you display a routing table, you will see something like this: show IP route static. So here we have two routes. So we come back with our previous example with the load balancing. Now I don't want this. I want only to keep one route, the primary route that will be used for forwarding, and in case it's down, the backup route, the second route will be used as backup. So what I do, I go back to the previous route, I remove it, and then I enter it. But here you see I can put the administrative distance. So I put it 10. So I change the value, and instead of the default value, which is 1 for static routes, I put 10. So now the router is going to look at the administrative distance that I assigned to my second route. It will find that it has a higher value compared to the static route, which default value is equal to 1 of the first one, of course, which is using default value equal to 1. So which one the router is going to keep? The router will keep the static route to the same destination, which has the lowest administrative value. So let's display. Now you see it will keep only one entry, the entry that goes through serial 000. That will forward packet through the exit interface serial 000. So only this is kept in routing table. What about the second one? So you can go back to the running configuration, and here you can see it. Okay, but this one, it will not appear in the routing table because the administrative distance is higher. So the router, for the same destination, the router will choose the route which has lowest administrative distance. Okay, so we have done that. So now everything is fine. Let me save my work now. Okay, now I go to RT4. RT4, so it's configured with the same thing. In RT4 I will display show IP route static. So I have these two static routes to this point-to-point links. Now what I do, I'm going to configure my router to forward packet destined to 172.16.00 like this. IP route 172.16.00, the subnet mask. What will be the exit interface? Now I will use this exit interface 0/2/0. So I will choose this one. Sorry, I will use this serial 0/2/0. All right. Okay. Now I will add another static route to the same destination as you see here, same destination, Of course, there is another way for RT4 to reach this segment, this LAN, by forwarding packets through the exit interface serial 000, and I will put this exit interface. However, I don't want this second route to appear as I have done with RT1 in the routing table. That's why the administrative distance that I will assign to the second route will be equal to 10. Okay, like this. When you display show IP route static, when you display now the routing table, you will see only one static route to LAN 172.16.0.0. If you want to see the other one show running, okay, you can see it only through the configuration file. It will not appear in the routing table because router will say, okay, I have two routes to the same destination, 172.16.0.0, and it happens that one route has a better administrative distance compared to the other one. Better, it means it has lower administrative distance. So I'm going to keep this route with better administrative distance, and the other one will be rejected from routing table, will not be put in routing table. Now, let's see what happens. If I go to host on segment 172.16.0.1, okay, so what I do from here, I'm going to indefinitely ping. I will ping 172.31.0.1. I'm going to ping this, okay? See what happens. Now, if I go to RT1, I do the same thing. Debug IP packet. And here you can see, for example, when I, okay, everything goes fine. Okay. Right. I will stop and debug all. Now what happens? All those packets sourced from host 172.16.0.1, they go through to destination 172.31.0.1. They go through the exit interface serial 000. Let's check also with another packet, okay, serial 000. Let's check also with the next packet from the same source. So the exit interface is serial 000, okay. All packets sourced from 172.16.0.1, they are forwarded to the same destination 172.31.0.1. They are forwarded by router RT1 through the exit interface serial 000. Okay, so everything is fine, and we see that the host is able to communicate with our web server hosted on server 172.31.0.1. Now look what happens. I want all this path primary route to go down. I go to this router, okay, and what I do, I simply I turn off the router. Look what happens now. Now this path primary route is down. Look what happens. Okay, still host 172.16.0.1 is able to communicate with the server. So let's go now to RT1. Let's go to RT1 and display the routing table, static route. We see now that RT1 is using the second route to the same destination, and it's forwarding all the packets through the exit interface serial 001. Okay, and we go to RT4. We display the routing table, show IP route, show IP route static, okay, and we notice also that RT4 is forwarding packets to segment 172.16.0.0 through the exit interface serial 000. Now both routers RT1 and RT4 are using the backup route in order to establish communication between this host and the web server. So now this primary route is down, and you see communication is continuous. It was not interrupted, so everything works fine. Well, in real life, real routers, you will see that 1, 2, 3 packets will be missed, and then it resumes communication, but for this simulation everything works fine. How to check that? I go to RT1, I type this debug IP packet, and here I am. Okay, I notice that all the I will stop now and debug all. I notice that from RT1 all the packets sourced by host from host 172.16.0.1, they are forwarded using exit interface serial 001. Okay, Same story here. So it is forwarded through the exit interface serial 001, and same thing here. The packet sourced from host 172.16.01 is forwarded like this, serial 001. So it works fine. Now the router is forwarding all packets to this LAN through the serial 001. Same thing happens in RT4. Now let's see what happens if RT2 is brought up. So we turn on the router RT2. Of course, it will take some time. Let's notice here what happens. Okay, so everything is working fine. We still have RT1 forwarding all the packet through this link here. Now this link is up. You see, now request timeout. So communication is disrupted for a few seconds, and then it's going to resume. So two packets are lost, and then it will resume. Now we have to make sure that RT1 now is using the primary route. Let's go and show IP static route. You see now, in order for RT1 to reach this destination network 172.31.00, the exit interface is serial 000, which is this interface. Same thing for RT4. I can check my static routes. Same thing here to reach this destination network. Okay, so RT4 is forwarding through this exit interface serial 020, so which means that both routers resume forwarding their packets through the primary route. And if I want to double check and I want to see if really this works as intended, okay, let me just do this debugging and then I will stop. Okay, now let's look what happened. Let's see what happened. Now I have a packet hosted by 172.16.01. It's forwarded through the exit interface serial 000, which is fine. Another packet here, the second packet, is forwarded through the exit interface, which means now that we are back to the primary route. So floating static routes, it's a very nice strategy that allows you basically to to define primary routes. Generally, primary routes are those routes where you can send your traffic. Generally, the cost of these connections is very affordable. But in case there is a problem, primary route is down, you can always go to the backup route. Now, backup route is not active all the time because maybe it is using service which is very expensive. Just to provide some kind continuous provider. It provides service continuously. It doesn't want the service to stop. Okay, so backup route is there to help the two ends of communication keep the service running. Otherwise, once the primary route is back, okay, so the traffic will resume the traffic will resume following the primary route. Now, of course, using floating static routes, we'll assume that both routers identify at the same time that this route is down. That's why I turned off this router, because if you kill this link here, RT4 has no way to know that this link is down, so it will resume forward. It will continue sending packet through the primary route, and like this you will have a problem in communication, because RT1, if this link is down, RT1 knows that this point-to-point link is not working, so it's going to start using the backup route. But the problem, RT4, when it sends back the reply will continue to send them through this route here, because RT4 does not know if this point-to-point link is down or not. It does not have any clue about it. So this is the issue. This is the problem. And the other way around is true also. If this link is down, RT1 has no way to know the link is down, so it continues sending all packets through the primary route, and RT4 is going to send packet through this link here, so it's going to reach, but for the reply will go this way. RT1 will continue sending replies through this point-to-point link, and this link is not working, so you will have a mess and communication will be disrupted. That's why here I choose to disable the router or to turn off the router in order for the two point-to-point links to go down. Like this, the two routers, we know that the two links, all this path is down, so they will both agree to use the second path. Actually, not agree, they are not negotiating but they both use this backup route at the same time. Now, if you want something much involved, if you want to learn to teach the router how to know if another segment which is not directly connected is working or not, you can use the IPSLA. IPSLA technique provided with support by Cisco routers, which is a great technique, where router keep on watching on specific interfaces. Once this interface goes down, then it will trigger some action and events. I hope this video was useful, and if you like these videos, please you like the videos and subscribe. Thank you.